Here we go. All right, so let's finish up this page. Get your notes out. Come on. I know that the last thing in the world you want to do is listen to me. But, no, I know. But you don't love me enough to want to listen to me after you've had lunch. I know that. But that's okay. We're going to get this done, and then we're going to do a couple of these word problems, okay? All right. So, Emily, you calm?
Yes.
All right, we're ready to do problem. We'll be ready for D. Here we go. All right, how do we start? Can you remember from lunch a minute ago? This looks a lot like one we just did, but it has a pretty significant difference. We're going to put these two together, and they're going to go together as x squared plus 3x. This is a little bit of a harder problem, and I think you'll see why in a minute. We're on the back of 29. We're on problem D. So now what do I do? Remember, the base on LOG is 10. So 10 to the negative first. Oh, wait a minute, wait a minute. 10 to the negative first is x squared plus 3x. What's 10 to the negative first? 110.
Yeah, a little bit. One. Cool.
All right, now what?
0 equals x squared.
So we can subtract that 110, but wait a second, you guys. What in the world am I going to do with this equation? That is not a very pleasant looking thing.
Quadratic.
I could definitely right now use the quadratic formula. If you are at all worried about the fractions, you could also times everything by 10. And then you can do that. There's nothing wrong with that. You can multiply everything by 10 and then use the quadratic formula if you want to. You can do it at any point. If you leave it like this, though, you're going to have to be dealing with the square roots of some fractions. So it might be easier to go ahead and times everything by 10 to get rid of the fraction. And then, all right, let's review our quadratic formula. X equals negative b, good, plus or minus the square root of b squared minus 4ac all over, whoops, 2a. Let's see. 940, is that what you said?
Yeah.
Boy, I don't know if this is a mistake or if I meant to do this. That's kind of yucky, isn't it? But I need to, right now, I'm going to go to my calculator and I'm going to get some decimals for this because I have to be able to check and see if any of them are extraneous, right? So I'm going to need a calculator. I think I may have made a mistake when I copied this, but oh well, it's okay. It's all right. We can deal with it. Tell me if you match me. For one of my answers, I got .0330. The other one I got negative 3.0330. Does anyone match either one of those?
I matched the first one.
Now, assuming I'm right, the because I'm not gonna test you over a problem this wild and wacky. But assuming I'm right, would .03 be okay? Does that keep everything positive, .03? That's okay? What about -3? Does -3 work in here? No, so that one would be extraneous. So the only answer we can use is the -30 plus root 940. All right. Sorry about that. I really don't want to have you worry about that one too much. What I was thinking, who knows? Let's try the next one, see if it's a little bit better for us. Okay. Anybody have a thought on how we might get started? Yeah. Remember, if you don't remember anything else, kids, today, remember that you have to put your logarithms together when they're in an equation. So these are going to go together, and they're going to go together. How? How am I going to put these two things together into one logarithm?
X squared minus 6.
I have to multiply these together because that's a plus. So that's going to be x squared minus 16. Paul?
So the logs don't combine, they just stay as 5 instead of combining?
Oh yes, they stay as 5.
Okay.
They stay exactly as they are. Instead of having 2, you have 1, but it's exactly the same.
Would there ever be the time that the logs are different?
Oh, Chris says, what happens if this is a base 5 and that's a base 4? Ah! We can't do the problem, right? So that won't happen.
Would you ever, you wouldn't give
Oh,
us
I
one of
wouldn't do one. Believe it or not, I want you to be successful.
those? I believe it.
All right, now what?
5 squared.
5 to the second equals x squared minus 16. So 25 equals x squared minus 16. What?
0.
Subtract 25. Gotta get that 0. 41. That's not a very nice number, is it? Unfortunately, the world is full of not nice numbers. So I'm gonna say the answer is plus or minus root 41. Here I am. I'm gonna add that 41 to the other side and take the square root. Is that legal? Can I do that? Now go back to the original problem. Could you put a negative root 41 in here? No. You could put a positive root 41, but not a negative. So your only answer is root 41. If you're unsure, you can type that in on your calculator and get a decimal at 6 point something. So 6 point something would be okay. All right. Now look at this next one. All of a sudden things are a little bit different. What's different about this one? Can you tell?
Logs on both sides.
Oh, logs on both sides. Now, that does not change our first step. See over here, you have 2 of them. You're not allowed ever to have 2 of them on the same side. Just like here. The first thing we have to do is put them together. So how will those go together? The log base 3 of what?
4x.
Yep. 4x. Now, this is where it gets different. Over here, we did 5 to the second equals x squared minus 16. That's what you do if you have one logarithm. What do you think we might do since we have one on each side?
7.
What?
No.
Yeah, these cancel. You can get rid of those. You have exactly 1 on each side. So doesn't it make sense to you that 4x should equal x minus 1? So 3x equals negative 1, and x equals negative 1/3. Now let's go back to the beginning. Can we put a negative 1/3 in here? No solutions. The only answer we got, and we got it correctly, we did not make any mistakes. The only answer we got just doesn't work. 2 more, and then we're going to have some fun, okay? Hang on.
Yes.
Hang on. 2 more. All right. All right, here we go. Take a look at it. Tell me how we're going to start. I heard somebody say something about dividing. These 2 need to be put together. And when I put them together, for the first time today, I'm going to divide because of the subtraction. So what's going to go inside this parentheses right here? 2x divided by 3? Now look, I got a logarithm on both sides. What do I do when I have a logarithm on both sides? Cancel them out. So I have 2x over 3 equals 5. Everybody see that? So 2x equals 15. And x equals 15 halves. Which you can write as 7 1/2 or leave it as 15 halves, whatever. It's up to you. Those kind are actually easier, I think, than the other kind. 1 more, here we go. Joseph, step 1, or this is problem H now. Step 1.
Divide.
Yes, you want to put these 2 logarithms right here have to be put together. So we're going to put them together as 1 logarithm. And you're right, because that's a subtraction, when I put them together, they'll go together as a division. So Joseph, what's going to go in here?
3 over x.
3 over x. Beautiful. Now, Marley, what are you going to do next?
Cancel the loss.
Yeah, since you have 1 on both sides, you can cancel them out. And we have 3 over x equal to 12. Thank you, Anna. Which means 3 equals 12x. And x equals 3/12 or 1/4. Oh, you're not done. Oh no, now the fun begins. Yeah, no. Now we're gonna do, no, come on now. Here we go. Let's take a look at the next page. These are the word problems. This is the very last thing we have to do. Normally I make the kids memorize the formulas. I'm not going to make you memorize them because we are getting close to the end, and I'm sure you got a lot of stuff getting ready for exams. So I'm not going to have you memorize them. Okay, we're going to use them. But up at the top of your paper, I want you to write these 2 formulas. You have space up there at the top. Write these. Normally, like I said, you have to memorize them. You'll have to remind me to give them to you probably on the exam and stuff. But here are the 2 formulas that I want you to write down. We're gonna talk about all the, yeah, then we call that the PERT formula. Did you study the PERT formula last year?
Yeah.
Okay, good, and you know what's going on. See, here I thought I was gonna just have all the fun with you, and here you've already had all the fun, but oh well, that's okay.
It's called PERT or PERP?
Perp, like P.
PERT, look.
Oh my god.
I thought it was perp.
All right, so here we go. The first problem, listen, this might be a question you might have. How long is it going to take me to double my money if the bank pays this much interest compounded quarterly? The formula that you use is this one. This is called your compound interest formula. This is called your continuous growth formula. So since the problem says interest compounded quarterly, I'm going to use my compound interest. Interest compounded quarterly. Does that make sense to you? The word compounded quarterly is kind of a clue. Compound. Alrighty, now here we go. In the formula, did you use this formula last year too? Okay, do you remember what everything means? What does the A mean? Do you remember? It's what you end with. It's the end amount. So A is what you end up with. So in our problem, how much money do I want to end up with? $2,000. Does that make sense to you? $2,000? Now, P stands for principal, and not like Mr. Orland, but as your initial investment. So P is your starting amount. P is what you start with. So what is the P in our problem? 1,000. Colleen, you pay attention back there? So that's 1,000. Now this is a number 1. So I mean it is what it is, it's a 1. R, you might guess, is the interest rate. If you put money in the bank, they're going to give you interest, and it's at a rate. When I put my interest rate into my formula, Curvin, I'm going to put it in as a decimal. So how would I put in 2.5%? 0.025. So that's what goes in right there is 0.025. Now the formula has 2 ends. Those are the same number. And that stands for the number of times per year that you compound. So when we say in this problem we compound quarterly, that means 4 times a year. Quarterly means every 3 months, 4 times a year. If we said compound monthly, that would be 12. Sometimes it's compounded annually, which would be 1. So I'm compounding quarterly, so I'm going to put a 4 here and a 4 here. And then T stands for the number of years. And that is my variable. Would you agree with that? It says how long will it take? Now you're looking at this and thinking, I'm supposed to solve this? You already know how. We already practiced some today. Eventually, we want to take a logarithm, because when we take a logarithm, this guy will become a coefficient, right? But I can't do it yet. What do I have to do first? I have to divide by the 1,000. Kids, you must always divide. Remember, we talked about that in those other problems. So dividing by 1,000 would give me a 2 over here. Agreed? And then I have let's go ahead and figure out what that is. 1 plus 0.025 divided by 4. 1 plus 0.025 divided by 4. Did you get 1.00625? Now, you don't have to do that. You can leave it like this if you want. It just looks kind of messy and scary. Now look. Take the log of both sides, and gang, what beautiful thing happens when we take the log of both sides? This guy right here ends up out here. So we have the log of 2 equals 4t, the log of 1.00625. Now what do you want to do? Okay, so we'll divide both sides. So we have the log of 2 divided by the log of 1.00625 equals 4t. Everybody okay with that? If I divide both sides by the log of 1.00625? Alright, so I can type that in my calculator. Log 2, don't forget close parentheses, divided by log 1.00625. Did you get 111?
Yeah.
Okay, and that sounds like a lot, but remember, that isn't the final answer. What do we still need to do? Divide by 4. So take that number, just hit divided by 4. Don't retype it, just hit divided by 4. And how long does it take? 27.81 years. So almost 28 years to double your money at that interest rate. Isn't that fun?
Did we have our answers 28, or do we need to?
It would depend on what the direction said in terms of rounding. So if it said to the nearest year, you would say 28 years. If it said to the nearest tenth, it would be 27.8. It just kind of depends what the directions say. All right, we're going to do one more, and then I will be quiet. So let's do the next one. Now, I will give you the formulas, but I will not tell you what all the letters stand for. You need to know how to use the formulas, okay? But I will give you the formulas. So number 2, how much will be in the account at the end of 10 years if 1230 is invested at 3.125% compounded monthly? So your first decision is which formula? The one we just used, or are we gonna go with PERT? The one we just used because it says compounded monthly. Correct? All right, so here we go. What goes in for A? How much am I ending up with? That's what I'm looking for. So A is what I'm looking for. How much am I starting with? 1230. There's a 1. What's my interest rate? 0.013125. Is that right?
Yeah.
Divided by 12. Why 12? Compounded monthly. And what's my exponent? 120. Why is it 120? Because N is 12, monthly, 12, and we're doing it for 10 years. Does that make sense to you? Now, I want to show you a huge difference. I erased my other problem because these take up so much space. But look back at problem number 1. They're same formula, same kind of general idea, but totally different problems. Where was our variable, our unknown, in the last problem? It was an exponent. when your variable is an exponent, you're gonna need logarithms, okay? If it's not an exponent, we're just gonna type that in. There's nothing to do here. There's no more work to show. You're just gonna type it in. So as always, we'll start with the parentheses, so type it with me if you have your calculator. 1 plus 0.03125 divided by 12. Now just type that much. Type 1 plus 0.03125 divided by 12. Did you get 1.0026 something? Okay? Now that's this. Now what do we need to do with that? We need to take it, use that button right there, to the 120th power. Did you get 1.366?
Yeah.
So that's all of this. Now we're going to take that answer and do what with it? Times 1230. And the answer is 1680.53. Now this is a money amount, so it doesn't make sense to round it anything past 53 because it's cents, right? So it came out to be 5279 53 cents. So this is how much would be in the account. Alrighty. Tomorrow we will pick up then, after we take our review quiz tomorrow, we'll pick up with the rest of these word problems. And then we'll be done and we'll start reviewing for our chapter 3 test. And then we will start